Welcome all. Today I am just going to take the topic on adversarial search. So, what is meant by adversarial search? So, it is a one type of a searching strategy used to make an optimal decision in competitive environments like games where opponents try to defeat each other. So, that is the mainly of adversarial search. So, it is one of the branch of economics that can use any multi-agent environment as game that can be provided that impact of each and every agent on others is significant, whether the particular agent or cooperative or competitive. So this is about adversarial search. So it is also known as a game playing technique where each and every agents are surrounded by competitive environment. A conflicting goal is given to agent that is also said to be as a multi-agent. So these agents compete with one another and try to defeat other one another in order to win the game. So especially searching is based on game theory, agents that can be of competitive environment. So according to that game theory, whenever a game is played between two players to complete the game, one has to win the game and other automatically loses. So that is the exact definitions of an adversarial search. Such a conflicting goal that can be said to be as an adversarial search. So it is one of the game playing technique. So those games that can be of an human intelligence as well as an logical factors that can be of any like lucky factor can be also including as well as excluding in the other factors. So that can be of tic tac toe, checkers as well as chess. Only we are just having a two players game. So especially our mind or a brain that can be especially work on it. If it is of not working, no other luck will be works under the characteristics of adversarial search. Especially adversarial search, it can be merged into reasoning plus creativity that can be used in the application of game playing as well as in game theory. So we can be represented it is an either one player game or a two player game, but initially at the final goal it will be often either win or lose. So that is an about our adversarial search. So now we are just going to see what are and all the structure and how the knowledge can be represented by using of game playing or game playing search using of adversarial search. So there will be of having lot of characteristics. One is of initial state, player, action, result, terminal test as well as finally utility. Initial state. So whenever we are just going to start with the player 1 or player 2, we are just going to start only with the top node, that is often root node, that is will be of an initial state in the tree. So that can be shows all possible as well as the to pick any out of it. So whenever the interaction between the two or more players in each and every game or each and every player payoffs that can be affected by the decision and decision made by the others. So second one is player that can be represented as an yes. So generally we are just going to have min as well as max. That is only we are just going to see about in an adversarial search. So wherever we are just going to represent max, it can be begins with the game. At least it can be pick one best move and place x in the empty square. Similar like also min. So that is also we are just going to follow with the action based on it. So next third one is it will be of action. It will be follows the strictly defined by the behaviors that the player has to choose between what can the players do. So both the players can make the moves in the empty box and the chances by chances how the each and every state that can be moves to it. So that is about the action. Result that can be represented of yes comma a. Result can be represented of S comma A, the moves that can be made either by the player 1 or player 2 that can be represented as a min or max that can be finally decided by the outcome of the game. So this is about the result. So terminal test, when all the empty boxes are filled, it can be terminating that the particular start of the game has been close to it. So that will be often terminal test. And utility, after concluding each and everything, So you want to get the award or reward based on the particular max or min. So whenever the question is given, according to the concept, we are just going to move either max or min, win or lose. Accordingly, the prize will be given to them, the reward will be given to them. So that is will be often playing. So that especially the game playing search that can be leads to the adversarial search. So next is that we are just going to see about, there are two different types of algorithm that can be classified into adversarial search. One is of normal search and another will be of an adversarial search. Normal search, we are just going to follow the actions to reach either the goal or to finish the game optimally. Whenever we are just going to find the solution for it, we are just going to find whenever finding the problem for it, we are just going to exactly reach the destination for it after, by the knows about the initial as well as final state. So we are just going to reach only the optimal solution for it. So that is often normal search. Whereas in the adversarial search, the result depends on the player, which we are just going to decide the result of the game. So we are just going to have two different types of algorithm we are just going to concentrate in adversarial search. One is minimax algorithm and another one is alpha beta pruning. So first we are just going to see about the minimax algorithm or min-max algorithm. So min-max algorithm. So it is a backtracking algorithm. So mainly it can be used in the game theory to find the optimal move for a player. So here we are just going to use the decision strategy game theory. We are just going to either win or lose the game. So minimizing the losing chances as well as maximizing the winning chances. So here we are just going to represent for minimax algorithm or minimax approach, we are just going to use the two different types of concept. One is max and one is min. So that can be represented as an maximizer as well as minimizer. So maximizer, it is used to tries to maximize the score, whereas minimizer is used to tries to minimize the score. So it will be of, in terms of an approach, we are just going to concentrate of increases chances of winning the game or decrease the chances of to max to win the game. So that will be of a concept. And while the result of the game, mainly it will be having some reward or award for the particular function, whether they will be having a proper approach for this concept using of backtracking approach. For that only we are just going to have a heuristic function propagating from the initial node to root node. So especially it will be often best choice for selecting the backtracking method. So and it is also used for board games like chess, tic-tac-toe and as well as in checkers. So it is also used in the concept of decision making in AI agents for competitive scenarios. So that is the main usage of a min-max approach. So now we'll see the algorithm that is used to represent the min-max algorithm. So we are just going to, it is a two-player game. So it is concept, the main concept which will be of an adversarial search that can be used with a backtracking approach. Minimum of node n comma depth d comma player p. So if automatically the depth is equal to 0, so we are just going to return the value of the node. So since it is a two player game, we are just going to initialize as a max as well as a min. So for example, if a player equal to max, that can be represented as a maximizing player, we are always setting that maximum value that can be represented as a notation called alpha equal to minus infinity. So for each and every value of a child node, value equal to minimax equal to minimax of child comma depth minus 1 comma minimum, alpha equal to maximum of alpha comma value, finally it will be returns the value of alpha, else it will be of, we are just going to choose for the minimum. So for that we are just going to set as alpha equal to plus alpha. For each and every child of a node, we are just going to initialize the value equal to minimax of child comma depth minus 1 comma max. So here we are just going to check the condition for alpha equal to minimum of alpha comma value. So and finally it will be returns of alpha. So this is the concept of how we are just going to Initializing the maximum player would be called as an minimax with the starting node, depth node, as well as the minimum or maximum node. So this concept exactly how we are just going to represent by using the example. You can clearly understand the concept of minimax algorithm. It is an back propagation algorithm, backtracking or back propagation algorithm. We are just going to especially concentrate in an adversarial search. So this is one example for your concept. So here the nodes are given. So initially it will be starting with A, B, C, D. A is the root node that can be have the child process of B, C, D, and it can be subdivided into B1, B2, B3. C can be represented as in C1, C2, C3. D can be represented as D1, D2, D3. So we are just going to start with the bottom up, that is depth equal to 0. From that we are just going to check each and every condition for it. So normally we are just going to check the condition for it. So the values for b1, b2, b3, it can be represented as 3, 12, 8, and here we can be represented as c1, c2, c3, 2, 4, 6, and d1, d2, d3 is 14, 55 and 2. So now at the stage we are just going to check the condition of maximum. Maximum, if you are just going to check, it will be of under the condition of alpha equal to minus infinity. Now you will be having the condition of b1, b2, b3. So now you are just going to check the condition of maximum of minus infinity comma you are having 3, 12 and 8. So which is here we are just going to have the minimum value for it. So minimum in sense we are just going to have the condition, so which is having the minimum value compared to all the 3, 3, 12, 8. So which is having the minimum value? 3 is having the minimum value. So you are just going to insert the value 3 in the B position, as well as you are just going to compare C1, C2, C3. So here which is having the minimum value? Here 2 is the minimum value compared to all of 3, and 14, 5 and 12 which is having the minimum value? So D1, D2, D3, 2 is having the minimum value. So now you got the value of 3, 2, 2. So now you are just going to find the alpha equal to minus infinity comma 0. So you are just going to set the value for this component, and you are just going to have 3, 2, 2. So 3, 3, 3, 2, 2, you will be having the value called maximum. Now you are just going to compare with minus infinity comma 3, 2, 2. So which is having the maximum value? 3 is having the maximum value. So we are just going to assume compared to 3 to 2, 3 is having the maximum value. So we'll be inserting the 3. So that is a maximum value for finding out the min max algorithm. So next we are just going to find the second example. So here we are just going to have the, so again we are just going to start with this same example of other. So here we are just going to have these are the values. So from that we are just going to conclude each and every value. So now we are just going to find out the min max algorithm for this particular tree. So the root node is 9. We are just going to find out from the beginning, the bottom up, depth equal to 0. So here we are just going to use of comparing minus 6 and minus 1, 2 and 9. So we are just going to compare each and every value. So here we are just going to compare minus 6 and minus 1. Minus 1 will be the least and 2 will be here, and we are just going to 9 as it is replaced, and comparing with minus 9 and minus 8, minus 8 will be there and 9 will be there. So comparing each and every nodes like this, you will be getting the value of 9. So it is another example we are just going to have for this min max algorithm, similar like it. So whenever we are just going to have the depth value be above from it, it will be of either min or max. According to that we are just going to calculate the depth value, which can be replaced with alpha. Finally we are just going to replace this value, and finally we are just going to compare all those value according to the condition alpha equal to either maximize or minimize. We are just going to set the value, and finally we are just going to according to the condition of child depth minus 1, either maximum or minimizing. For a maximizing player, we are just going to assume either alpha equal to minus infinity or alpha equal to plus infinity. We are just going to set the value and finally find the which value will be of an top root node from the depth node equal to 0. We are just going to find the what is the root node of it, and that will be of an maximizer algorithm. For example, here we are just going to consider 4 3 5, so 2 1, everything we are just going to consider. So here we are just going to consider the minimum value. So compared to 4 3 5, 3 is the minimum value, and comparing 2 and 1, 1 is the minimum value, 4 2 3, 2 is the minimum value, so 5 4 7 it will be of 4. So like that we are just going to conclude, and you will be getting the three value of 31247203031, and finally from that value which is having the maximum value, you are just going to compare both this value according to the condition of maximizer of minus alpha comma these values, which is having the maximum value, it will be of 327033. And finally after concluding this, you will be having other next will be of minimum. So you'll be getting the value of 2 and 0 after finalizing with the comparison of minimum value. And finally at the top root node, we are just going to have the maximum value. So comparing with 2 and 0, which is having the maximum value, 2 will be of having the maximum value. So final answer can be represented as 2 is the maximum value, and it can be represented with the path node also. So this is an example of